Okay, good morning. Now we'll see the internal forces in beams. The beam may be defined as a skeletal structural member that resists externally applied loads by bending. External forces are applied in a direction that is perpendicular to the longitudinal axis of the beam. So the overall force equilibrium in the beam as a free body is maintained by appropriate support reactions, maintaining equilibrium with the externally applied loads. So due to the action of the forces or the loads in a beam, inside the beam internal forces are developed due to the bending action. Okay. So the main internal force resultant in a beam is the bending moment, which is obtained by considering the moment equilibrium. So how we are finding out the internal forces? By considering a free body of a part of the beam, we expose the internal forces including the reactions acting on the free body. So you have to expose what are the internal forces, and we have to include in the, we can expose it by including the reactions acting on the free body. So the main internal force resultant is the bending moment. And how we can obtain this? This is obtained by considering moment equilibrium equation. What is the moment equilibrium equation? Sigma m equal to 0 on a free body exposing the section at a location x along the horizontal axis of the beam. So you can find out what is the bending moment at any section on the beam by considering the free body of that portion and exposing all the forces acting including the external loads and reactions and finding out what is the bending moment at a particular section. So this bending moment vary along the length of the beam. So when length increases, it increases or it may decrease. So there is variation of bending moment along the length of the beam, and due to this variation of the bending moment, equilibrium demands another force resultant. So this force resultant is known as shear force, and this is obtained by considering the force equilibrium equation sigma Fy equal to 0. So our aim is to find out what are the internal forces. We can find it out by drawing the free body diagram of the beam, considering all the loads including the reactions. We can find out what are the internal forces, and for that you have to consider the free body diagram of the beam for a particular section, and we have to expose the section and find out what is the moment by taking the algebraic sum of moments of all the forces acting on that particular section. So due to this variation in bending moment along the length of the beam, there will be the rising of another force resultant, that is the shear force, and this can be obtained by considering the force equilibrium equation sigma Fy equal to 0. Now we'll see what are the notations and sign conventions we are using. So the usual notation we are using is for load intensity, it is taken as W, small w, shear force capital F, or sometimes we can use SF, bending moment capital M, or we can use it as cap BM. So small x is the distance measured from origin, say the left support along the axis of the beam. So if you have a beam like this, we are taking the section line x6 and we are taking the distance small x from the left support. So here it becomes 0 and 0 to x, like that. Now we have to see about the sign convention. So what are the sign conventions we are following when we are taking the shear force, finding out the shear force at a section of the beam? So shear force is positive if it tends to move the left portion upward relative to the right portion. So here you can see this shear force is trying to move the left portion upward related to the right portion. Then it is now taken as positive shear force. Or you can take all the forces to the right of the section downwards as positive and to the upwards as negative. So if you have a beam like this, and it is subjected to a number of forces, and if you are taking a section line like this, and if you are taking the forces, all the forces which are acting to the right of the section acting downwards are taken as positive, and all the forces to the left of the section acting downwards are taken as negative. So for negative shear force, negative shear force is taken as if the shear force is negative, it tends to move the left portion downward relative to the right portion like this. If the tendency of the shear force is to move the left portion downward relative to the right portion, then it is taken as negative shear force. Or you can take all the, if you are considering a beam and if you are taking a section line, all the forces to the right of the section acting downwards as positive. Okay, and all the forces to the right of the section acting upwards as negative. So this is the sign convention we are following in the case of shear force. Now we'll see what is the sign convention of bending moment. Bending moment is positive if it tries to sag the beam. So here you can see a beam. Now let this be the section line. So we are taking the moment right clockwise, right anti-clockwise. This moment is this is a moment which is acting in the anti-clockwise direction. This is a section line. Right of the section anti-clockwise produces positive bending moment, that is sagging bending moment, and hence left clockwise is positive. So all the moments to the right of the section line is taken as right of the section anti-clockwise taken as positive, and all the moments to the left of the section clockwise is taken as positive. So this too will cause a sagging bending moment. So this sagging bending moment is taken as positive. Now this is the negative bending moment. So if you are taking a section line here, the forces to the moment which on the right of the section line which produces a clockwise moment, right clockwise produces negative. So right clockwise bending moment is negative and left anti-clockwise negative. So these two will produce a hogging bending moment. So if the curvature is upwards, it is hogging bending moment. If the curvature is downwards, it is sagging bending moment. So these are the section lines. So about the section, we are always defining the sign convention for bending moments. So to understand the meaning of the terms shear force and bending moment, let us consider a beam may be subjected to loads 30 kN and 10 kN point loads. So you consider a section XX at a distance 4 meter from the left support A in the beam. Let RA and RB be the vertical reactions. So first step is we have to find out the vertical reactions. In order to find out the vertical reaction, let us take the sum of moments about B and equate it to 0. So when you take moment about B, what is the moment of RA about B? This is RA into 10. 10 is the total distance. So this is producing a clockwise moment. This is producing a clockwise moment. So positive minus this 10 is producing an anti-clockwise moment about B. So minus 10 into 8. This 30 is producing an anti-clockwise moment about B. So this is minus 30 into 3. 3 is the moment arm. So this is equal to 0. So we can find out what is the reaction at A. RA is equal to 23 kilonewton. Okay. So we will get the reactions RA equal to 17 kilonewton and RB equal to 23 kilonewton. This is obtained by using the equation sigma V equal to 0 and substituting all the vertical forces. RA plus RB is equal to 10 plus 30. You will get RB equal to 23 kilonewton. Now you imagine the beam is cut into two pieces at this section X6 and is separated as shown in figure. We have to find out the forces experienced by the section. So you consider any one portion of the beam, and first let us take the left hand portion. And what is the transverse force experienced in the left hand portion? Transverse force in left portion is equal to 17 minus 10, which is equal to 7 kilonewton. So here the resultant transverse force is 7 kilonewton, and we have assumed the downward force as negative. So you have got this 7 as positive. So this 7 kilonewton is acting upwards. Okay. Now we have to find out what is the moment experienced at this portion. So we can write what is the moment experienced. Moment is equal to 17 into 4, because this distance is 4 meter. This is 4 meter. So this is producing a clockwise moment, plus minus this is producing an anti-clockwise moment. This distance is 4 minus 2, 2 meter. So minus 10 into 2. So you will get this moment is equal to 48 kilonewton meter. So you are getting a positive sign. So this is clockwise. So you are getting a moment positive, and it is value is 48 kilonewton meter. Now let us consider the right hand portion. You consider the right half portion, that is the right hand portion, and we first will write the transverse force. What is the transverse force experienced on the right hand portion? This 23 is acting upwards, 23, 30 is acting downwards, minus 30. So this will create minus 7 kilonewton. That is, we are taking the forces, 30 is acting downwards, negative. So this 7 will also be acting downwards. So this is 7 kilonewton acting downwards. Now let us find out what is the moment experienced. Moment experience is equal to this 23 into this distance is 10 minus 4. So this is 6 meter. So 23 into 6, it is producing an anti-clockwise moment. So minus, then this is producing a clockwise moment, plus 30 into, what is this distance? This distance is 6 minus 3. So this is 3 meter. So into 3. So you will get minus 48 kilonewton meter negative. It is anti-clockwise moment. So this moment is anti-clockwise. Same value 48 kilonewton meter. So thus the section XX considered is subjected to forces 7 kilonewton and moment 48 kilonewton meter. So this force 7 kilonewton is trying to shear off the section, and hence it is called the shear force. The moment bends the section, and hence it is called the bending moment. The shear force F and bending moment M at a section can be defined as: shear force at a section in a beam is the force that is, it is the unbalanced vertical force that is trying to shear off the section, and it is obtained as the algebraic sum of all the forces including the reactions acting normal to the axis of the beam, either to the left or to the right of the section. And bending moment at a section in a beam is the moment that is trying to bend the beam and is obtained as the algebraic sum of the moments about the section of all the forces including the reactions acting on the beam, either to the left or to the right of the section. So this is how you have to define shear force and bending moment. Thus, the procedure to find shear force at a section is to imagine a cut in the beam at the section, consider either the left or right portion, and find the algebraic sum of all the forces normal to the axis. To find bending moment at a section, imagine a cut in the beam at a section and find the algebraic sum of all the moments about the section due to all the forces either to the left or right of the section. Okay. Thank you.